So let me ask you this. From yesterday, okay, when we look at this type of reaction, it's a combustion type because we have a hydrocarbon. How do we know that we're dealing with a hydrocarbon here? On the reactant side, how do you know that's a hydrocarbon? Because it has carbon and hydrogen in it, okay? So if we have a hydrocarbon like this, combining with oxygen, giving you the same byproducts every time, CO2 and H2O, we know that that is a combustion type. Now, one of the things we wanted to ask you, or that we did, we put two equations up there. One was what, C2H6, the other one was C7H16. And it was a trick question, and one of the things that we said we wanted you to recognize, for instance, what key signature you might be in music, what type of defense you might be facing in basketball. The same thing could be said for even with that of football. So we have a quarterback in here, backup maybe. Okay. So when you look at that in that sense, it's the receiver's job to read the defense, right? Then it's the quarterback's job to read the defense and the receiver, okay? So it's a little more difficult for them. But there again, in musical sense, you need to pay attention to, again, the key signature. So from yesterday, what did we say is significant about this point in the reaction? Whether it's what or what? Odd or even. So since we're dealing with an even number, what should we do right away? What did we do yesterday? And the reason some of you may not see this is that it was the back end of that presentation we were just talking about no more than 2 minutes ago. Okay? So, if it's even, you do what? What do you do to this if this number's even? Someone's got to know. Perhaps, well, it doesn't have to. Just guess. Multiply it by what? Someone said it. No. You get the same thing if you multiply by 1. You multiply it by 2. You double it right away. Now, this is why we'll show you the wrong way on how that happens, okay? So if we do this, carbon, hydrogen, and oxygen, we know we've got those, okay? So carbon's left. So if you don't want the right way, don't write this down immediately. So we got 6, 1, hydrogen's left, hydrogen's right, oxygen's left, oxygen's right. Okay? And what happens is people may forget that. Okay, so this is what happens if you don't double it right away. You're going to look at this and say, okay, so 6, we're going to put a 6 here. That's fine and dandy. But that changes this to what then? 6 times 2 12. Plus 1 more gives you 13. Okay? We're still all right. We've got 14 to 2. So what would we do here? You would take it times 7 and say, well, that's all right. But the problem that we have is we still have an odd number for our oxygens over there. Okay? We can't take this times 6.5. Okay? That would give you 13, but that's not what we want to accomplish here. So, since that does not work, the right thing to do right away, we said, is do what with that hydrocarbon? Take it times 2. So if we do that, 2 times 6, okay? So how do we get 12 over here now? Okay, up to this point, is anybody just totally lost, don't know where these numbers are coming from or anything? So left outside, are we all right? Left middle, middle, right outside. Okay. So, what does that do to our hydrogens now? 14 times 2 gives you 28. Okay? So, how do we get this up to, oops, we got to do this carbon first, sorry. We've got 12. If we want 12, what do we put here? Okay? So carbons are balanced. 12 times 2. Okay? So sometimes you may want your calculator. You don't have to use your calculator. That's entirely up to yourself. But how do we get this hydrogen now up to 28?
H2O times 14.
Okay? So what you can do, and until you get a really in-depth understanding of this, is say 12 times 2, that's 24, and 14 times 1, 14. You add them two together and get 30 what?
8.
38. Okay? So now, when we took that times 2, so now we've got 2 oxygens on the left and 38 on the right. So what would we do?
Take it times 19.
Okay, so we're just taking 38, dividing by 2, and getting 19. So you have 4 blanks. In those 4 blanks, you write what?
2, 19, 12, 14.
Okay. Is there anyone, well, possibly, but sitting out there and thinking, this information is way above and beyond what we think our learning capacity is? Is anyone thinking that? Maybe no one wants to. And I get it. It's human nature. Nobody really wants to say anything. But this just helps set the stage for general chemistry for those of you who go on to take that not only in high school but also in college. All right. Can we erase this? Left outside, left middle, middle, right middle, right outside. Okay. Let me put some more examples up on the board. Okay. So what is a coefficient then when it comes to these reactions? What's a coefficient? Is that a small number or a big number? In size, not saying 2, 3, 4, 5 in that size. If we have CO2, that little 2 is called a what? Subscript. And when you put 12 in front of the CO2, that 12 is called a what? That's called a coefficient, okay? So we had done this example yesterday, all right? And at some point today, we're going to see an example of this reaction here, okay? So when this mercury 2, we're talking about right here, when that mercury 2 decomposes into its parts, why is that 2 behind the oxygen? Since oxygen is a gas, what does that mean? It's diatomic. Who else is diatomic? Halogens. Who else? Nitrogen is. One left. Hydrogen. Okay? Not the noble gases because they're already stable. Okay? So, notice the subscript after the oxygen. Remember, gases are diatomic, but so are the halogens. Okay? But not the noble gases because they're already stable. I think you're going to see these next 2 weeks. To me, this is one of the best times a year. One, college basketball. Two, spring can't be denied for hopefully that long. I think if it probably in a couple weeks, it's going to be one of them times you can step outside and just listen. And what will you hear in Mother Nature? Say that again. Possibly robins and other birds that go through the migratory process. Who thinks songbirds are relaxing? I do. And when it comes to the finch family, there's goldfinches, but what type of male bird sings really pretty? It's a type of finch, but it's not a goldfinch. They can. They have a red crown to them. They got a red chest. It's a type of finch, though. And you wouldn't. What type? Well, they're called house finches. So yeah. Sometimes you name birds differently. Like for instance, ducks. I have a hard time differentiating ducks. But. All right. Not that anyone goes home. Did anyone watch Wake Forest and Duke last night? Anyone see the highlights? Holy cow, I can't believe this was called. Wake Forest makes a basket to pull within one. There's 7 seconds left. Okay? Duke takes the ball out, and when they do that, he still has the ball. He's out of bounds, but steps on the baseline. What does that mean? That's a turnover. So there's 7 seconds left. Wake Forest ball has the ball now, and it's 70-71. They had 2 good looks at the basket, and one is rolling around the rim as the buzzer goes off, but it doesn't fall in. Crazy. Yeah, that's what I mean. College basketball, it's an exciting time at this point of year. Even if you're not a basketball fan, it's still refreshing to know that spring is hopefully here. Just some positive thoughts to think about. Because as we all know, if you believe the weatherman, this Saturday, again, I'm tired of snow. Maybe no one else is. Could you repeat that? Father Time or what? Maybe Mother Nature's upset at Father Time. That's why she keeps snowing. But guys don't say stupid things, do they? Anyway, okay. All right, so we want to do this one, and then, all right, so this will be the last one. Then I want to take some time to show you a video then. As you can see, even with this last reaction, a lot of this involves just trial and error, okay? It's not always going to work that first time you go through it. Sometimes you're going to have to start over and try again. Because if I'm not mistaken, I think one of the things people like to talk about is even Thomas Edison failed, I don't know how many times, trying to invent the light bulb. It only took once where he was finally successful. It happens. But one of the things we talked about, even when you go out in society and going to your associated tech school or workforce or the military or college, you're making mistakes. That's going to happen. But we try not to repeat them, and hopefully we learn from them. Okay, does everyone have this information that wants it? No. Okay. Take a peek at that, please. I don't like grabbing people's papers. All right. I think that's kind of rude to do that, so that's why. Okay. Easy money, right? No? Maybe? Okay. Something. Okay. Now, does everyone have this information that wants it? Okay. Chances are what's going to happen tomorrow, I'm going to hand out your next paper that will involve classifying reactions. Okay? So, going to, because of time constraints, we can go back and look at this on the science wheel. Got it. Okay. Because everyone works at different speeds. That is true. Okay. So, one of the things that we want to show you is when it comes to these polyatomic ions, okay? Let's say, for instance, we've got some of this. So why did that 2 go there? Because what charge does lithium have? +1. The carbonate ion has a charge of negative what? -2, okay? So now we've got +2 and -2 adding up to 0. And let's so some aluminum sulfate. What's the least common multiple between 3 and 2? Okay? So this is one sulfate ion, SO4. What is 6 divided by 2? Okay? So the answer you get, you put below. 6 divided by 2. Or excuse me, 6 divided by 3. Okay? Now, when you look at these subscripts, here, 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 and here, we've got 1, 2, 3, 4, 5. Of those 5 subscripts, how many of them are going to be on the right side for sure? There's 2 of them. 2 of them have to go to the right side. I'll let you take a guess. Which elements would they belong to? The carbonate ion and the sulfate ion. Okay? What we mean by that, okay, this has to go over, and so does that, because those are part of the formula. Okay? These subscripts were added to balance out the compound, like you learned from last chapter. So everything that you've learned up to this point, we continue to use. Okay? So in this double replacement reaction, what type of ion bonds with one another? 2 positives or 2 negatives? Or a positive and a negative? Positive and a negative. Okay, so give me a positive ion in this reaction. Lithium. So the positive ion of this compound, okay, bonds to the negative ion of this compound over here. So LiSO4, remember, this has to come over for sure because it's part of the formula. Okay? Plus, what's another positive ion? Aluminum, right there, is going to bond to the negative ion here, which is what? CO3. And again, that carbonate, that 3, has to go over because that's part of the formula. the 2 was added to balance out the compound. The 2 in the aluminum was added to balance out the compound. Now, okay, charges do not change. Positive 1 and negative 2, does that add up to 0? No. So, what would we put here? 2 divided by 1 gives you 2. 2 divided by 2, okay? What's the least common multiple here? Okay, so 6 divided by 2. 6 divided by 3. Okay. So as we look at this, okay, who would have problems balancing this? This is kind of a little more of a tougher one. Do you want to try it yourself or you want to work on it together? Okay? Some people who are really, really good at this, they may have it figured out already. Is that anybody? Yes? Okay. Yep, that's right. This is one that looks like it's really tough, but it's really not that bad. But that just comes with experience. Does anyone else think they have an answer? Yep, that's right. It's giving you headaches? No? Okay. Good, good, good. Is anybody frustrated and just say, I need help? Okay, I'll go by 1 minute and dig into it. Yahtzee. Did it have this number in there? Twice? That's right then, chances are. You're a Twins fan, so I can say you're probably right. Since you're a Twins fan, you're pretty smart then. You say way to go? Yeah, good thinking. Better to be a thinker rather than a stinker. Okay, there's about 10 seconds left, but okay, so give me some elements. Lithium. That's probably it, right?
Yep.
Lithium's left.
2.
Lithium's right.
2.
Carbonate's left.
1.
Carbonate's right.
3.
What is that? Okay. Aluminum's left.
2.
Aluminum's right.
2,
Sulfate's left.
3,
Sulfate's right.
1.
Okay. Setting up to this point. Is anybody? I still don't get this. Is that anybody? We need to have a baseline to start. Okay. So when we say lithium, we got this little 2 behind it, right? Okay. That's where that's coming from. Okay. So how do we know we've got 2 aluminums here? Because there's a 2 right by there. That's where that 2 is coming from. How do we know we've got, this is 1 sulfate ion right here. How do we know we've got 3 of them? Because it's got a 3 on the outside. Keep them together. Okay. So what might be the most logical place to start? You're going to have to pick one of your polyatomic ions, either here or here. Okay. So how many carbonate ions are on the right? 3. Okay? Because it says that right there and right here. Okay? So if we put a 3 here, distribute that through the entire compound. 3 times 2. 3 times 1. Okay? So it looks like we're getting closer. Maybe yes, maybe no. But since we've got 6 lithiums on the left now, how do we get 6 lithiums on the right?
Take times 3.
So if we put a 3 there, 3 times 2,
6,
3 times 1,
3,
what does that tell you? 3, 1, 3, 1. And again, these numbers are coming from up here. That's where those numbers are coming from. All right. So, just one of the things I want to do, if I can look at someone's paper again, I just want to see just the front side. Okay? So, if you had to take a guess on look at numbers 1 through 5, pick an equation. 4. Okay. What type of, well, we haven't talked about those types. Since we haven't done that yet, we don't know what single replacement reactions mean yet. It's getting a little ahead of myself. Okay. If we had, my gosh, a problem quiz next week or even tomorrow, who would be saying, oh, no?
I'd be saying it.
Okay. Now, one of the things that's going to happen in this chapter, there's going to be 2 problem quizzes. One that deals with just balancing only, just like your paper. Tomorrow, what's going to be handed out is not only just the balancing, but also the classifying. That'll be problem quiz 2. Now, what's going to happen, ideally, tomorrow we're going to get into the classifying the reactions. We're going to hand out your next set. These are due tomorrow, okay? And next week, hopefully we can put some of this information to use over in the lab for an activity. And we'll probably have a problem quiz over balancing these. So, who has a really good understanding of this, do you think? So for those of you, if you feel you don't have a good understanding, look at these people who have their hands up, okay? Chances are they'll probably help you if you decide to ask them, or myself, or an upperclassman. It's your personal choice. Okay. We will continue with this tomorrow.